In this video, we're going to discuss dropout. We'll discuss dropout, and then we'll discuss dropout in PyTorch. So as you recall, we have a decision boundary, and then we have samples, and y equals 1 is red, and y equals 0 is blue. So in real life, we'll have some noise in our data, and if we train a neural network on the noisy data, our decision function will look something like this. And this is the true decision region, and as you can see, our model doesn't perform well. And the reason is, it's fitting the noise, not the actual data. Now there's several ways to solve this, and one way is using regularization. And we're going to talk about dropout, a popular regularization technique for neural networks. There's other regularization techniques, and we're not going to cover them in this course, but if you understand this section, this should be no problem for you to pick up on your own. So there's two phases to dropout. There's a training phase and the evaluation phase. So let's go over the training phase. So we have our neural network, and we apply dropout to the hidden layers. So what we do is we start off a probability. And this probability basically tells us how likely we are to turn off an individual neuron independently. So in this case, we have 0.2. And for the first iteration, with a probability of 0.2, we'll turn off that neuron. And I like to use the expression kill a neuron. So in actuality, what we're doing is we're actually calculating a value for that neuron, but we're multiplying the outputs of that neuron by 0. So let's see what happens for the second iteration. So for the second iteration, we randomly turn off or kill a neuron. And as you can see, a different set of neurons are randomly and independently shut off. And then we calculate the forward step, and everything else remains the same. We repeat the process again for the kth iteration, and basically that's it. So just a note, this isn't really important, but if you're curious and you know a little about neural networks, what PyTorch does is it normalizes the values in the training phase. Other methods may do it in the testing phase. But again, you don't really have to worry about that because PyTorch will take care of that for you. So let's see what happens if we choose a higher probability. So we set probability equal to 0.4. As you can see, we killed or turned off more neurons. 0.8, we killed more neurons, and 1, we killed all the neurons. So in PyTorch, you can also select a probability for each layer, and usually the more neurons per layer, the higher the probability. So now let's go over evaluation. So all we do is we calculate the forward step as usual, and we produce a prediction. And that's pretty much it. So let's compare a model with dropout and without dropout. So we have this model over here, and this did not use dropout. And as you can see, the validation accuracy was 88%. Now this model used dropout with a probability of 0.5, and this validation accuracy was 91%. And these are results for each iteration. And as you can see, the model without dropout performed better on the training data, but performed worse on the test data. And the model with dropout performed better on the validation data. And here's an example with regression. And as you can see, the line in green used dropout, and it fits the actual line in yellow much better than the line with no dropout in red. So let's see how to implement dropout in PyTorch. So we have our custom class or module, and in this case, I put a parameter to set the dropout level, and we create a dropout object, and in the forward step, we call the dropout method on our output after every linear layer and activation. We can do the same thing for sequential, and we have our linear layer, and we simply add the dropout layer preceding the linear layer. So just a note, in PyTorch, you have to set your model to train when you use dropout, and you have to set your model to evaluate for the prediction step or forward step. And that's it.